We've finally gotten here, where all of our hard work on crafting a dataset may finally pay off in building a quality machine learning model. But before we dive in, let's first try to define what machine learning actually is. Now, if you ask 10 people, you may get 10 different definitions of what machine learning is. As an illustration of that, here's a few widely accepted definitions. The first is one of the more well-known definitions. It comes from Arthur Samuel. Samuel originally coined the phrase machine learning in 1959. Yeah, it's been around that long. Samuel was a pioneer in computer gaming and artificial intelligence. He defined it as the field of study that gives computers the ability to learn without being explicitly programmed. So the next is from Tom Mitchell, who is a computer science professor at Carnegie Mellon. He defined it as follows. A computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T, as measured by P, improves with experience E. More or less just saying that machine learning is a set of programs that improve on a certain task with more experience or data. I think that gets a little closer to a reasonable definition, but still a little bit abstract. The next is from the University of Washington, without any name attributed to it. And I do like this one. Algorithms that can figure out how to perform important tasks by generalizing from examples. This is the first one that really gets at the core. Machine learning is training an algorithm on a set of known examples with the clear goal of generalizing to unseen examples. That's the entire purpose. The last example is from NVIDIA. They say machine learning is the practice of using algorithms to parse data, learn from it, and then make a determination or prediction about something in the world. I like this one as well because it gets to the piece of parsing data while maintaining what I liked from the previous example about learning from given data and use that to make a prediction on new data and generalize to say something about the world. So there are a few different viewpoints on how to formally define machine learning. The point being is that there is no clear, agreed upon definition, but hopefully given these 4 definitions, you'll start to develop an idea of what machine learning is. Now, there are 2 broad types of machine learning. The first, supervised learning. This is where you have an explicit label, and it's a task of inferring a function from that labeled training data to make a prediction on unseen data. So again, like we saw before, fitting a model for the purpose of generalizing and making a prediction on unseen data and saying something about the world. Supervised learning is the type of machine learning that we'll be doing in this class. Unsupervised learning is where you don't have any explicit labels, and it's about deriving structure from the data where you don't know the effect of any of the features. In other words, you don't have anything you're trying to predict necessarily. You're just trying to back out some sort of information or structure using the variables that you were given. A couple of quick examples. An example of supervised learning would be a spam filter. The machine learning model would predict whether any given email is spam based on known information about the email. So email content, maybe sender, recipient, what time it was sent, maybe the structure of the email, things like that. An example of unsupervised learning would be grouping together similar emails into distinct folders based on the content. There is no right or wrong answer necessarily, but if a model can identify that these 15 emails are all in regards to a vacation to Italy, and those other ones are about planning a certain family gathering, and then it can group those together into their own little bundles. That's what unsupervised learning is.